In this question, it is given that P1 and P2 are the lengths of the perpendiculars from the origin to these two straight lines, and we are interested in the value for P1 square plus P2 square. Okay. The moment I read this line, lengths of perpendicular from the origin to straight line, this particular portion, lengths of perpendicular from origin to the straight line, automatically normal form of the equation comes into picture. So these are the two given line 1, line 2, and the normal form of any equation is given by x cos alpha plus y sin alpha is equals to p, where this is the straight line. If this is the straight line whose equation is this in normal form, then P is nothing but perpendicular distance from the origin to the straight line. This is P, and alpha is this perpendicular making with the positive direction of x-axis. This is the whole situation. Okay. Normal form and this picture both comes hand in hand together. Okay. So you need to remember this particular situation with respect to this form always. Now, the idea is to calculate the P of this equation and this equation, because as per the question, P is what? P1. Actually, P1 is what? The perpendicular distance from origin to this line. This is P1. And P2 is what? Perpendicular distance from origin to this particular line. So here we are trying to convert both the equations in normal form and then eventually calculate P, which is perpendicular distance from both lines. So P1 will be perpendicular distance of the first line and P2 will be the second line. Got it? Now, let's focus on first line. This and this. We need to compare this. So what I can see over here it is sec theta and here it is cos alpha. Okay. So we need to convert this equation. We need to do such manipulation such that there is cos in place of this sec by anyhow. Okay. So what I'm going to do is I'm going to write sine and cos in place of sec and cosec. So I'm going to convert. So sec is 1 by cos theta. Yes, and this will be 1 by sine theta and this is equals to a. And if I take LCM, what do I get? X sine theta plus y cos theta is equals to a sine theta cos theta. Cool. But wait, x has sine theta, but I want cos in multiplication with x, isn't it? So what I'm going to do over here is write x cos 90 minus theta in place of x sine theta. Yes, now we have cos in place of sine. Yes, and similarly, if this is replaced by pi by 2 minus theta, I'm going to replace this by y cos what again? Okay, y sine pi by 2 minus theta. So y has sine as a term. So here alpha, if I compare this normal form with this equation now, pi by 2 minus theta is alpha. Okay, and on the right hand side, what do I have? Same thing, a sine theta cos theta. And if I multiply 2 and divide 2 on the right hand side, what do I get? A sine 2 theta by 2. Isn't it? A sine 2 theta by 2. Now, if I compare this equation with the normal form, what do I get? I clearly can see this is P of first line. Isn't it? On the right hand side, we are left with just P, and P is perpendicular distance from the origin to this particular straight line. So P1 in this case will be what? A sine 2 theta by 2. P1 is sorted in similar manner. We need to talk about straight line number 2. So here it is already cos theta is sorted, but here it is minus sine involved. Okay, and sine theta is also sorted. So I'm going to adjust this minus sign over here by taking it inside the sign. So y sine minus theta, because minus sine theta we already know is sine of minus theta, but wait, here it is cos theta and here it is sine minus theta. That will not work because in this form the argument inside the cos and sine are same. So what I get to do over here, cos minus theta is cos theta. So I'm just applying a minus sign. It will not affect my equation at any cost. So x cos minus theta plus y sine minus theta now can be written as a cos 2 theta. And this is nothing but P2. Perpendicular distance from the origin to this particular line number 2. So now we have P1 and P2. P1 is A sine 2 theta by 2. P2 is A cos 2 theta. Now we are interested in this value 4P1 square plus P2 square. So 4P1 square, okay, which is sine 2 theta by 2 whole square plus P2 square will be cos 2 theta. And we have a over here. Let's not forget A, okay. Now if we solve this, 2 square and 4 will get cancelled out. A square is getting common from both the terms. Sine square 2 theta plus cos square 2 theta. Do I need to say it as 1? That means the final answer of this particular question is option C. Okay. In this question, it is given that there is a line which is passing through point of intersection of these two lines, and we are interested in the locus of circumcenter of the triangle formed by line L and coordinate axis. Okay, so the moment we read first line, this first line in itself is a concept. Which concept? Family of lines. So first line says there is a line L which is passing through the point of intersection of two lines, and the family of lines concept says what? There are two lines L1 and L2. Then the equation of third line, which is passing through the point of intersection of these two lines, will be given by L1 plus lambda L2 equals to 0. So let's plot the diagram. There are actually two lines. Line number 1 is this, let's say. Line number 2 is, let's say, this. Okay, L1 and L2. L1, L2. And this is the point of intersection, and there is the third line. And this is the line, let's say, L, which is passing through point of intersection of these two lines. And now we are interested in circumcenter of the triangle. Which triangle actually? This is A, this is B, this is O. So this triangle, circumcenter of this particular triangle, I am interested in. This is in fact a right angle triangle. Isn't it? If you carefully observe this, this is a right angle triangle. And we are interested in circumcenter of this right angle triangle, which will lie on the midpoint of the hypotenuse. So that means overall we are interested in locus of midpoint of this AB. Let's say this is H comma K. Okay. Now how to get the equation H comma K? For that, let's write the equation of this line L. Cool. Let's write the equation of this line L by using L1 plus lambda L2 equals to 0. So the equation of line L would be what? This is L1. This is L2. Right? So L1 plus lambda L2 is equals to 0. Now let's club these terms together. So here I'll be getting coefficient of x would be what? 1 plus 2 lambda. Coefficient of y would be what? 2 plus 3 lambda. And last I'll be having 1 minus lambda. So this would be the equation of line L. Got it? Now, what I actually want this time is, this. The coordinates of A. To get the coordinates of A here, what I want is the x-intercept of this particular line. For that, I need to put y equals to 0. So, when I put y equals to 0, x-intercept would be what? X-intercept would be what? Lambda minus 1 whole upon 1 plus 2 lambda. Yes, and similarly, to get the coordinates of point B, I need to get y-intercept. Y-intercept would be what? Lambda minus 1 whole upon 2 plus 3 lambda. When I put x equals to 0, I'll get y-intercept. When I put y equals to 0, I'll get x-intercept. Isn't it? Now, h comma k is the midpoint of these 2 points, A and B. So, A would be what? X-intercept comma 0. A would be what? X-intercept comma 0, and B would be what? 0 comma y-intercept. Right? So here 0 plus x-intercept by 2 would be what? H. Isn't it? H would be what? 0 plus x-intercept by 2, or rather x-intercept will be equals to 2h. Isn't it? X-intercept would be equals to 2h, and y-intercept similarly would be equals to 2k. So what I have got over here is the value of 2h in terms of lambda and the value of 2k in terms of lambda. Yes. So the agenda actually, now the last thing which we will do to calculate what? The locus is to get the value of lambda in terms of h, to get the value of lambda in terms of k, to get the value of lambda in terms of h actually by this equation, and to get the value of lambda in terms of k by this equation. And then we have two values of lambda side by side, one in terms of h, one in terms of k. We just need to equate those things. So here 2h would be equals to what? This. So lambda would be equals to this, minus 2h plus 1 whole upon 4h minus 1. Similarly, if you calculate the value of lambda in terms of k, you'll get this. So now you have the value of lambda in terms of h, the value of lambda in terms of k. Now you just need to equate this to get the locus. Let's cross multiply quickly. 6 2s are 12, hk minus 2h minus plus 6k minus 1 will be equals to what? 4 4s are 16, hk plus 4h minus 4k minus 1 minus 1 gone. These two can club together so that I'll be having what? 4xy. H being replaced by x automatically, k being replaced by y. 4h minus 2h would be what? 6x plus 6x. And these two, 6k and 4k, so I'll be having what? Minus 10y. So the final I'll be having plus 6x plus 4xy minus 10y is equals to 0, which is exactly matching with option A. Got it? In this question, it is given that the set of values of alpha for which the point P alpha comma alpha square minus 2 lies inside the triangle formed by these three lines. Okay. So let's first of all visualize the situation. So there, let's say three lines AB, BC and AC. And these three lines are forming a triangle ABC, and inside ABC we have a point P as per the question. So let's draw these three lines. So y equals to minus 1 is catching my attention. So y is equals to minus 1 is line BC. Okay, so it will have a point B and a point C on this line. Okay, so how to get point B? By solving these two lines, isn't it? So for B, y would be equals to minus 1. Yes, and if you put minus 1 over here, what would you get? X equals to minus 2. So minus 2 comma minus 1 is the point of intersection of these two lines, right? Similarly, if I solve these two lines, what would I get? Point C. So y equals to minus 1 will give me x equals to 2. So point C will be 2 comma minus 1, right? So B and C we have got. Now we need to think about point A, which is intersection point of these two lines. And if you solve this, you'll get 0 comma 1 as the point. So it will lie over here 0 comma 1. This is point A. These are the three lines actually, right? And point P alpha comma alpha square minus 2 is lying inside the triangle. Now, point is lying inside the triangle. That means position of a point is given to us, and we do have a concept related to this. What is the concept? Position of a point with respect to a line. Yes, position of a point with respect to a line concept. Let us recall, we have a line L, we have a point P1, X1, Y1, we have another point P2, X2, Y2. These are the 2 points. And we clearly see that these 2 points are lying on the same side of line. So if we put those points in this particular line, we'll get 2 values. So first one would be what? L1P. When you put X1, Y1, you'll get some number. Okay, you'll not get a 0 because point is not lying on the line. Either you'll get a positive or negative. So when both the points P1 and P2 are lying on the same side of the line, then product of these two values L1 P1 and LP1 and L2 P2 will be positive. What is this? So if X1 Y1, if you satisfy that point on that line, and if you're getting a positive number, that means P2 will also give you a positive value. That means they are lying on the same side. And here P2 is there. So X2 comma Y2. If you put that line, if you put that point, these 2 points on this line and take a product, you'll get a negative. That means sign will be opposite. Okay. And always remember, whenever you talk about the position of a point with respect to a line, there will be 2 points. There is no left, no right, no top, bottom, above, below, nothing. There will be 2 points, and we are talking about the relative position of the 2 points. Yes, we cannot talk about a single point position with respect to a line. So please keep that in mind. So now how to apply this concept in this? That's the major fun part. So here we can see that P is the point which is lying this particular side of the BC. So there is only 1 point, and I have already told you we need at least 2 points to apply this concept. And if I talk about the line BC this time, only line BC, so we do have actually 2 points in our picture. Can you figure out? Actually, the point are A and P. Can you clearly figure out whenever there is a triangle and there is a point which is inside the triangle, so the third side, with respect to third side, in this case BC, so with respect to BC, P and A both are lying on the same side of line. Yes, that is the concept we need to apply. This is the triangle, the neatly drawn triangle, and the first thing which we have figured out is A and P must lie on the same side of BC. Now what to do with it? So BC is the line, y plus 1 equals to 0 is the line, isn't it? So now P and, we have already studied this, point P and Q lie on the same side of line. Then what happens? If you put P, if you could put Q in that particular line, and if you take product, you'll get a positive value. Yes. So here y plus 1 is equals to 0, and you need to put 0, 1 in that line. So 0, 1 if you put, so x is equals to 0, there is no x, but y is equals to 1, so you'll get 1 plus 1. If you put this line, this point in this line, you'll get 1 plus 1. And if you put alpha, alpha square minus 2 in this line, what would you get? Alpha square minus 2 plus 1. Only this. This is what? Second point. Because there is no x to put. So only y, alpha square minus 2 plus 1 equals to 0. If you take product of these two, what would you get? A positive number. So yes, what do you have right now is alpha square minus 1 greater than 0, and if you solve this by method of intervals, alpha plus 1, alpha minus 1 greater than 0, you'll have what? Minus infinity to minus 1 union 1 to infinity as the answer. This is the first case. And you actually think about, if you think about how many cases can be there. So if we take AB line, then point P and point C would lie on same side of the line. Second case. Similarly, if you talk about the third line, which is AC line, again P and B would lie on same side of the line. So there would be 3 cases. Now just calculation part is left. 3 cases, one by one you need to talk about all the 2 cases, rest 2 cases, and take out the intersection of the alpha. So first is this. Second and third we are yet to figure out. So here B and P must lie on same side of AP, right? So AP is what? AC. AC is what? X plus y minus 1 equals to 0. So when you put minus 2 comma minus 1 in this, what would you get? Minus 2. So minus 4 you're getting. Okay. And when you put alpha comma alpha square minus 2, you'll get what? Alpha plus alpha square minus 2 minus 1, and this would be what? Greater than 0. Now we just need to solve this to get the answer. So here same thing, minus 2 minus 1 minus 1. Alpha plus alpha square minus 2 minus 1. Product of these two would be greater than 0 because both points lying on same side of the line. So if you solve this, you'll get alpha square plus alpha minus 3 less than 0. Now we need to solve this with method of intervals. For that, solve it by formula method. So there will be 2 roots. Minus 1 plus minus root 13 by 2. Okay. So that simply means that alpha minus first root let's mark as A. Alpha minus second root less than 0. Right? If you plot this from A to B, you'll get your answer where A is the smaller root. Yes, and B is bigger root. Yes. So alpha range in this particular case is coming out as this. Let's talk about the third case. Third case says what? C and P. C and P must lie on same side of AB, where A is what? Y minus X. Y minus X. Okay, or rather X minus Y plus 1 equals to 0. This looks cool. This sounds better. X minus Y plus 1 equals to 0. Which are the points? 2 comma minus 1. So 2 plus 1 would be the value of first point. And again alpha minus alpha square plus 2 plus 1. Product of these two would be what? Greater than 0. Just like this. Right? And if you solve this, what would you get? This alpha square minus this time. Alpha square minus alpha minus 3 less than 0. Similarly, if you calculate the root, you'll get these two values. And since this is a negative sign, less than 0 sign. So that means from smaller root to bigger root, our alpha will be there. So there are actually 3 values. So values of alpha, let's list the values of alpha over here. Alpha belongs to minus infinity to minus 1. Union 1 to infinity. And this is the range of alpha. Alpha belongs to 1 minus root 13 by 2, comma 1 plus root 13 by 2. And the third alpha belongs to what? Minus 1 minus root 13 by 2 and minus 1 plus root 13 by 2. Yes, and if you take intersection of all the three values, what would you get? This. Alpha belongs to 1 minus root 13 by 2, 2 minus 1 union 1 comma minus 1 plus root 13 by 2. Just simple intersection, you can take it. And this is the final answer. So final answer is nothing but option B. So option B is the correct one. Got it? In this question, we need to figure out the equation of a line which makes an angle of 15 degree with the positive axis and cuts off an intercept of 3 units on the negative y-axis. Okay. So let's understand this one by one. So we are given with an angle of inclination of this particular line. So what do we know? Theta. If we know theta, then by this formula m equals to tan theta, we will know slope of this line. That means slope of this line is known to us. Okay. And the next thing which is given to us is y-intercept, isn't it? So y-intercept is nothing but minus 3 because the intercept is cut off on a negative y-axis. So y-intercept, which we denote by C, is nothing but minus 3. Slope intercept. Both are given. So we'll use what? Slope intercept form. Okay. So slope intercept form, first of all, let's calculate slope from this theta. So as per the question, what do we need? This is the, let's say this is the line, okay. This is the line, since this is minus 3. So negative intercept on y-axis and this angle is 15 degree. Theta is 15 degree. So what do we know about theta? M is equals to tan theta. So M will be tan 15 degree. Now we need to know the value of tan 15 degree. Now some of you might remember the value. This is nothing but 2 minus root 3. Okay. But if you don't remember this value, then you can easily calculate this value by the formula tan A minus B. Okay, so we'll use that formula, but before that, we need to understand that by this form actually, we need to calculate the equation of straight line, which is y is equals to mx plus c. Now y is equals to m, or rather tan 15 degree x plus c, that is minus 3. Now we just need to know the value of tan 15 degree, which we already know, 2 minus root 3. So this is the answer, 2 minus root 3 x. So I'll recommend you to remember this value, tan 15 degrees 2 minus root 3. But if you still want to calculate this value, you just need to put 45 degree in place of A, 30 degree in place of B. If you solve this, what do you get? Tan 15 degree equals to tan A. That means tan 45 degree minus tan B. That means what? Tan 30 degree whole upon 1 minus tan A tan B, which is what? 1 plus tan A tan B, so which is what? 1 plus 1 by root 3. Now if you solve this, you'll get root 3 minus 1 upon root 3 plus 1. And if you rationalize this, what do you get? 2 minus root 3. Of course, you'll be getting 2 minus root 3. Please remember this value. Tan 15 degree is 2 minus root 3. So for this particular question, we do have an answer. So y is equals to 2 minus root 3x minus 3 is equivalent to this particular equation, which was given by option A. Okay? In this question, we need to determine the coordinates of foot of the perpendicular drawn from the point 1, minus 2 on the line y is equals to 2x plus 1. So let's understand the whole situation with the help of the diagram. So this is the situation. This is the line, let's say line is L and a point P, 1, minus 2. From this 1, minus 2, I have to draw a perpendicular such that this point, the intersection point is M. And this M is nothing but the foot of perpendicular from P on this line L. And we are interested in coordinates of M. As simple as that. Now, how to get the coordinates of M, which is foot of perpendicular? Now, to get the coordinates of M, we need to visualize this particular, we need to observe actually this particular figure very carefully. Now, I can clearly see that this M is intersection point of two lines. Which two lines? One line is L, y is equals to 2x plus 1, and another line. Another line is line formed by joining the points PM. Yes, intersection point of these two is nothing but point M. So we just need to solve these two lines, the equations of these two lines to get the coordinates of point M. But I have the equation of line L, but I don't have equation of line, let's say L1. which is line joining P and M. So how to get the equation of L1 is our concern in this question. Now to get the equation of L1, I need a point and I need a slope. Do you agree or not? I need a point on this line and I need slope of this line. And what I can see over here is there is already a point on this line, 1 comma minus 2 given in the question, isn't it? So point is sorted. Let's now think about the slope of the line. How to get the slope of this line? To get actually the slope of this line, I'm going to draw a 90 degree over here. Since PM is perpendicular to line L, this angle would be 90 degree, isn't it? And what I can clearly see over here is slope of line L is what? 2. Y is equals to mx plus c, that means m equals to 2. So slope of this line L is 2. Right? And slope of a line perpendicular to this line will be what? Negative reciprocal of this line. So slope of line L1 I have just got, which is equals to minus 1 by 2. So slope we already have minus 1 by 2. Point we already have. So what are we waiting for? We just need to apply point slope form to get the equation of line L1. Isn't it? So let's do that. Y minus y1. y1 is minus 2. So y plus 2 is equals to m. That means minus 1 by 2 and x minus 1. If you solve this, what would you get? You'll get the equation of line L1 as this. Right? This is L1, this is L1 and this is L. Okay? Solving these two equations will give me M. That means foot of the perpendicular from point P to this line L. Yes, we just need to solve this. Okay, to solve this, I'm going to multiply the first equation by 2 and add both the equations. Let's quickly do that. So I'm going to write 4x minus 2y plus 2 equals to 0. This is equation 1 and this would be my equation 2. If I add these two equations, what would I get? Okay, I'll get 5x plus 5 equals to 0. Cool. So x will be what? Minus 1. If x is minus 1, if I substitute x anywhere, let's say I'm substituting x equals to minus 1 in this equation, what would I get? Minus 2 minus y plus 1 equals to 0. This gives me y as what? Minus 1 only. Yes. So y is also what? Minus 1. X is minus 1. Y is minus 1. That will give me which answer is correct? Which answer is correct? Okay, option D is absolutely correct. Minus 1 comma minus 1. Got it?